Hello everyone, welcome back to MAT052. So this time we're going to continue with the hypothesis testing, more around the inequalities, and then we're going to take a little step further into developing what kind of test. So remember last time we took a claim, so let me just kind of go here real quick. We started out with some claim, let's say that the mu was greater than 35, and then we wrote a complement. You remember this? So we just said whatever the complement of this is, and then we did our hypothesis assignments. This was the null hypothesis because it had the equality, and then this one would be the alternate. We're going to pick this up. So what is the next step of the test? Once we get to here, what is this testing stuff about? And we'll go through that. Okay, so that's coming up in just a few minutes. Okay, so let's kind of review some of the things that we already know. If I have an inequality test, the inequality symbol less than or greater than, I want to do some graphing of these intervals, and basically these are open intervals when I don't include the endpoint, and then I could have this piece where I have some equality, and I'm going to do a little bracket here, okay? So we're shading a graph to show the solution to inequality. You need to think about what each sign means or what the problem is stating. So if the problem states less than, we'll shade to the left. If the problem states greater than, we'll shade to the right. So in these, there's a particular, it's not like the confidence intervals where there was a particular value included and we would want to do that. So here we may, if we're just shading, is strictly to the left. So first of all, we're just going to write an inequality in there, and in terms of x, so x is less than 4, so I'm just going to do x less than 4. Okay, so it's not including that, that's strictly less than, and then I'm going to go down here, and then I'm going to put some interval around here. So these are all of the x's to the left of 4, so I'm going to use that little open interval to let it know that 4 is not included, and then I'm going to go here, and I'm going to go all the way out to here. And I'm going to graph all of that out. And I'm going to shade that in. That lets me know that this is all the way through, and it could be anywhere. It could be the -10, -20, and this continues on. It doesn't just stop, okay, for that particular one. Okay. It takes at least 4 hours per week for math on. At the very least, I like to kind of emphasize when I'm doing this for myself, the very least, that's the smallest, the very smallest. Okay, so x would be bigger than or equal to 4. 4 is the smallest, and then all of the other ones, but x is the 4 is included, at least 4, and sometimes more. So how does that look when we're doing to do the graphing? When I want to represent this on the number line, here's my 4, so I'm going to go down here. The bigger numbers, these are the bigger size, so x is bigger than, I'm going to include it, so I'm going to do that bracket, and then I want to shade the bigger side. It said these numbers are in here, so I'm going to do that. I want to extend that out, and there's my bracket, okay? And that's the interval x greater than or equal to 4. Okay, so I'm going to let you do these. I think you understand here now. Candace must sell more than 71, more than would not include. So you have to look at those keywords to go through and get that. More than 71 would not include the 71, but they're bigger. So hint, x would be 71, and that would look something like that. Right? Okay. So I'm going to let you work on these. Go down to let's find something else. So now let's connect this to statistics. Where were we at? Okay, so we had some statement. So here, you remember before they had the HA, and I said this could be HA or H1. Different books or different texts will use different versions of this, but the alternate are 1 and versus H0, okay, that's usually universal or the null, okay. So what do? We made a statement, we took a statement. Let's do it with the proportion. let's say somebody can claim that the proportion of U.S. citizens prefer Mountain Dew, at least, so they think that the proportion is greater than 60%, greater than 0.0, not at least 60%, but greater than 60%. Okay, so that's more on this side. So I've got some claim. Proportion of U.S. citizens like Mountain Dew by 60%. Okay, so we'll have to do a complement. I've got to start out with some claim. If I don't have the claim, then I don't have the whole procedure set up that I can work with. I get my claim, I take whatever this is and do the complement of that symbol. The complement would be less than or equal to 0.60, right? So once I have this, then I do my assignment, H0, H1 or HA. Both of these are the same thing. This over here is using the H1, okay? So for this is what you're going to do our next step. The H1 or HA tells us the type of test. The type of test. Left-tailed, and I'm looking at it this way, so which way the version is. So the left tail is this, the right tail test is that, and then a two-tailed is the not equal, which is this or that. That is either less than or greater than. Okay. So I'm looking for these symbols in here, and it needs to be left to right. Here's the statement, and then the number. So if this was not equal to, we're going to do a two-tailed. If P or mu is less than a number, that's a left-tailed test. It points to the left. This points right, right-tailed test points right. Okay, so that's what we're going to look for in this statement, and that lets us hear what we're actually going to test is actually the H0. It's not the claim, it is H0 in each case. Once we get where we either reject or support the H0 hypothesis, fail to reject, fail to support, then we'll go back and then put in, well, which one was the claim. We'll have to work through that, okay? But right now, let's just say what type of critical region or types of tests. The critical regions is in a two-tail. Either tail is a critical, left-tailed. If I'm testing here, if it gets too far on the left, then we reject H0, and then right-tailed, okay? So write the null and alternative hypothesis for the following claim. Label the null and alternative and which one is the claim. Could be either one. Draw a graph of the sampling distribution and indicate if the test is a two-tailed, left-tailed, or right-tailed. So I'm going to kind of put this together and in terms of regions of how this thing is going to work out. So Elon University claims that at least 43% of undergraduate students are members of the fraternity and sorority community. So your claim is that P is greater than or equal to 0.43. At least 43%, could be more, okay? So now I need a complement. What's the complement of greater than or equal to? That's just the less than, and it's the very same numbers. Whatever that claim that you see that claim or wants to prove or disprove, but that is that from the statement, okay? Now what do I do next? Assign H0 and H1. I'll look for the one that's equal. That's the one I'm going to do H0. I always go H0 first. 0 comes first. And then H1 or HA comes next, depending on your textbook. Okay? But now we want to look if this is a two-tailed, left-tailed, or right-tailed test. And that's kind of the test that you're doing, okay? This always determines the test. Okay, so which way is this thing pointed? to the left, right? Points to the left, points left, so it is a left-tailed test. So let me tell you what we're going to do. We're going to draw this distribution, our bell-shaped curve. I do this much better on a board. But right here, this is the kind of our standard, normal, standard student's t distribution. This is going to be the 0. It says this is going to be to the left, and depending on what level we want to test this thing at, this is the left-tailed test. Okay, I'm going to have some amount alpha in here. That's to the level of the testing that we're doing. And what we're going to do is we're going to take the sample and go in here and check the sample. And if the sample lies here, we're going to fail to reject it. It's close enough. But if the sample is out here, and in this case the p hat is in there, and it's got to be the z for that p hat, the z score, t score for the p hat, then we're going to reject. So this thing is called the rejection region, RR, and this is the fail to reject, the FTR. RR is rejection region. FTR is fail to reject region. And who are we rejecting or failing to rejection? Always RR or FTR is always H0. So when we go and grab that sample and determine which one we're in here, if we fall into this little tail region, then we're going to reject H0. Then we have to worry about, well, is that the claim or not? We'll worry about that later. If it's failed to reject, if it's in here, we fail to reject. What are we failing to reject? H0. And then we'll worry about the claim. We'll have to unwind there. Okay. So that is our sampling distribution. That indicates the left tail. What we're going to have to do is basically determine some critical region here, that if we do the z-score here, is it over here or over there? Okay. Okay. So again, this is what you're doing. Again, you're writing a claim, doing the complement, assign H0, H1, H0 will always go with the equals. And then the HA will tell which way that points is either going to be right-tailed, left-tailed, or two-tailed. And let me show you what each one of them looks like real quick. This is a left-tailed version. This is a right-tailed version. That's what that looks like. And a two-tailed. So this is my Z alpha to the right, 1 minus alpha to the left. I should say maybe 1 minus alpha because it's in there. Z alpha. And then if I have a two-tailed, if I draw that picture, basically I'm going to have two rejection regions. Because it can be less than or greater than. You remember that alternate? Because it's saying it's supposed to be right there in the middle. This is here. This is here. Fail to reject is always in the middle piece of it. And this is my minus Z alpha over 2. This is alpha over 2. Just like we did confidence intervals in here, this is alpha over 2, half the area. And this is positive Z alpha over 2. Okay, so go through there, do those. This is again comes from HA. HA would have something less than something. Mu, P. The right tail would have something greater than something. And this would be something not equal to something, or less than or greater than. Okay, that would give you the two-tail. So go through, I'm not going to say which one these are, but that should get you started into writing kind of what these left-tailed, right-tailed tests are. Okay. Let me make sure nothing else going on, and just work on those pieces of it. Okay. Have a good day. Email me if you need me.